This is a final test of 41707. Came in with highly intermittent channels, distortion, typical of what is seen on an item that's decades old and has not been regularly serviced. What we're going to do is connect this to a test panel, and we're going to be able to feed in different signals. We're going to be able to listen to it and using dynamics such as radio stations, but more critically, we're going to be able to listen and actually see the quality of the signal using a dual trace oscilloscope and feeding in a signal from a laboratory generator. So what I'm going to do is explain what we have here. Obviously, that's the item. Up here, this item with, let's see if we can zoom in a little bit. Here we go. This item with two horizontal lines is a oscilloscope, dual trace oscilloscope. The upper line is going to show us the left channel. The bottom line is going to show us the right channel. This is a much more revealing test in person and in a video like this, because you really can't hear the quality. You can see it much better. Also, as we're viewing this to the left of the dual trace oscilloscope, there are two devices with zeros going across horizontally. Those are frequency counters. They're not going to be used in this test, but immediately above the top frequency counter is a nifty device by Nakamichi that is going to show us the amplitudes, and we could measure distortion with that. But there, though, it's going to also have, I don't talk too well today, it's going to also have two horizontal lines. The upper horizontal line will be in parallel with the oscilloscope. It's going to show us the amplitude of the left channel. Lower horizontal line is going to be in parallel with the oscilloscope, showing us the right channel. So we're going to turn this on, and let's back this out. Most of these devices have a typical turn-on delay of 5 to 10 seconds, and that's to allow the output stage to bias up correctly. So we're going to turn this on. 1001, 1002, 1003, 1004, 1005. There we go. So, and as we go through this test, I may need to switch over to dummy loads, because as we increase the volume, it's going to saturate the microphone on this camera. Also, it's going to override my voice and hurt my eardrums if we get this too loud. Let's just turn the volume up a little bit. And we're going to zoom in on the display. And I'm going to go through the different switches of these guys, so I'm not nice and stable and clean in the amplifier and that. So let's zoom in a little bit. So I'm going to go into the dummy load right now so I don't have to yell over this. And we're going to exercise some of the switches in control. This is the balance. That's your left channel, the upper display. That's your right channel, the lower display. We can go back and forth, and we can rock certain switches and controls. This is going to be the selector. All of these are highly oxidized, causing intermittent audio and distortion. Now you can see that signals are perfectly nice and clean. Here's some of your other controls. This is the tone control. This is subsonic. This is loudness. And this is muting. It gets us 20 dB of muting. There we go. So what I'm going to do now is do a frequency response display. We're going to set this to about 0 dB. We want to make sure the loudness is off, and we have our tones flat. So what I'm going to do is go through the entire audio spectrum, and what you should really be looking at is the two horizontal lines on the distortion analyzer, and see how much they change as we go from the bottom of the audio spectrum, approximately 20 hertz to 20 kHz, which is the top. We certainly can't hear 20K anymore, but this machine can probably turn it. And you'll be able to see the period on the oscilloscope change as they change the frequency. Right now, that's 400 hertz. So I'm going to go down to 40 hertz. Boom, 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 boom. That's 40 hertz. Now, if you look at this display here, it hasn't changed. Still at 0 dB. Now we're going to step this up, and you notice the period here has changed on the scope. So now we're going to step this up. There's like 63. And again, we want to keep watching this to make sure it doesn't change. And yeah, I think it's 200, that's 400, that's 600. I'm just going to jump all the way to the end, like 20K. And so now we're at 20K, and that is the hearing ranges of dogs and bats, and this still hasn't changed. We're still 0 dB. So this item is perfectly flat. I'm going to go back to 400 Hertz across the audio spectrum. And I'm going to go over now, and we can listen to some FM. Again, this is not going to be a critical test. The critical test is the visual when we use the sine waves.
844
There's your item.
0117. 844-308-0117. And make sure you join us here every Sunday morning at 10 for the
I'm going to turn this up.
generation.
One thing I'm going to do is I'm going to go back to the sine waves and just bring this up to full power. Okay, to do that I have to go into the dummy loads, turn that off. We also have to change the gain on this. Okay, so what's going to happen is full power is achieved when the top and the bottom of the sine wave. I'm going to zero in on this while I talk. Full power is achieved when the top and the bottom of the sine wave down a little bit. There we go. Start to flatten out and turn into a square wave. That is a severe distortion, and that's where an item blows up. So we're going to run this up just to that point. Whoa. Let me get a little less gain here on the scope. There we go. So right there is full. Whoa, I don't want to stay there too long. Right there is full power. And notice they're both equal, and it's a beautiful machine. Once again, should provide you many years of listening pleasure.
Rafferty there, huh? Right down the line. It's a good one. 6 minutes now from 9 o'clock. Gary Byron here with you up until 10 as we head back to the phones at 860-243-1360 local. We have a toll-free nationwide, 888-574-2723. Dave in Maryland. Good morning, Dave.
And that is the end of our final test of 41707.